Hi everyone, I'm Aishwarya. This video is part of CS 5610 Web Development course at Northeastern University for the summer of 2026. Every website we've ever used has the same few building blocks. So we're going to break them all down today, from HTML, CSS and JavaScript to databases and server architecture. And at the end we'll see how exactly all of them fit together. Let's start with going to google.com, a website we've all used hundreds of times. We are going to go to the network tab in web development tools, and here you see on the page load there are dozens of requests going from the browser to the server. Let's go to the first one, the HTML page itself. In the headers you can see the URL, the status code in the response, and the actual response itself, the HTML page, and this is a preview. All the requests here, the HTML, the JavaScript, the images, everything follows the same pattern. The browser asks for something and the server responds. But where exactly is this data coming from? Who is handling all these requests? That is what we're going to see today in this video. Let us start with drawing a concept map. So I have 5 layers on the left: structure, style, behavior, server and data. Let us start at the top, structure, and for structure we use something called HTML. HTML gives the skeleton of every web page, that it has buttons or sections or articles, etc. But it does not have any opinion about the color or the styling or any interaction that can be applied with JavaScript. It is only the structure, nothing else. And generally for HTML, each element consists of an opening tag, some attributes, the actual content, and a closing tag. This is the general structure of every HTML element. To identify one element on a page uniquely, we can use something called ID, and to identify a group of elements on a page, we can use something called a class. Generally in a HTML document, there are two sections, the head and the body. The head section has tags that generally represent the metadata of a page, whereas the body contains the actual content of the page. Inside the body we can have multiple semantic body elements like header, main, different sections, footer. Divs and spans are generally used as containers, whereas UL and LI tags can be used as unordered list and ordered list items. Another important thing to note about the HTML element is that it follows something called box model. It starts with the content at the center of it. And let us consider the border as something surrounding the content. Padding is the space between the border and the content, and margin is the space outside the border. This is the best way to remember the box model structure. For the next layer, adding style to a page, we use CSS. CSS tells the browser how the particular HTML element should look like. It gives layout, it gives the color, background color, font, etc. We also use something called Bootstrap, which is just a bunch of pre-written CSS. There are some pre-built components that we can directly use in a grid system so that we can avoid a lot of boilerplate code. So to know more about CSS, this is the basic syntax. We have a selector followed by a declaration block where we have property and value pairs. One important rule of CSS is we should always avoid using important. This will create a lot of conflicts when the browser decides which style needs to be applied to an element. As I mentioned before, Bootstrap is a bunch of pre-built responsive grid classes, and it has some UI components we can directly use. To add it, we can use the link tag with CDN, or we can use NPM. An important concept of CSS is CSS precedence or cascade. When multiple rules are conflicting for a particular HTML element, the browser needs to pick the winner, and that is usually done in the order of origin, specificity, and source order. So specificity ranking from the highest to lowest, it starts with inline styles, ID selectors for unique elements, and then class, so for multiple elements, and then pseudo element selectors. There are multiple ways of adding CSS style to a HTML page. One option is to add it directly in a style tag in the head section. Another option is to add a style attribute to a particular HTML element. But the general recommended practice is to use a link style sheet. We have different selectors in CSS. We can use a class with a dot. We can use ID with a hash. We can also point to different descendants and child elements of a particular tag. And even siblings can be selected. We also have another option of having pseudo classes. For example, we want a particular style to get triggered only on a specific state or a position of an element. For example, when you hover over a link, or when you have focus in an input text box, etc., we can apply certain styles. There are two concepts in CSS now that is very useful to apply layout to a HTML page. For one-dimensional layout, we can use Flexbox, and for two-dimensional layout, that is rows and columns, we can use CSS grid system. For Flexbox, we can use display flex, and then for the main axis, we can use justify content, and for the cross axis, we can use align items. And CSS grid, we can use it in case we want to display multiple cards. This is a good option. For the next layer, behavior, let us move on to JavaScript. For JavaScript, we specifically use ES6+. ES stands for ECMAScript because it has better features, and we've started using it since 2015. So JavaScript is what brings the page to life. It handles clicks, animations, loading data, etc. Also, JavaScript does not tap directly into the HTML. There is something called the DOM, which is the document object model. When a browser reads a HTML page, it builds a tree of HTML tags as nodes in its memory. JavaScript taps into the DOM to update the content or the behavior of the HTML element. So let us get into a little bit more detail. With JavaScript, we can have different variables. We can have constants, we can have variables for values that might get updated in the future. We can also have var, but it is generally advised to avoid. We can have different primitive types like string, numbers, boolean, etc. We can also have arrays, and we also have higher order methods on top of arrays like map, filter, and reduce, which will transform arrays but does not mutate them. To have key value collections, we can use a map, and to have a set of unique values, we can use a set. For key value pairs, we can generally create an object. This is for using structured data in JavaScript. To iterate over the keys of an object, we usually use for in, and to iterate over values of an array or any iterable like a set or a map, etc., we use for off. We can also create functions, and there are multiple ways of creating a function. The first one, directly with a function, we can declare it with a name and the content. We can have a function expression where we create a function and set it to a variable. Or we can have something called an arrow function. Next, we can move on to promises, which is the main concept or what we use to write asynchronous code. For example, we hit a URL and we want to retrieve the data. The page has to wait till it gets the data and then render it in the UI. In those cases, we use a promises. So we fetch and we have dot then, which maps and manipulates the data into the result that we need. Async await is just a change in syntax or a change in the way we write the code. So it makes the asynchronous code look like synchronous code. So we have an async, and for the fetch asynchronous point, we can add an await. So with every point where the code needs to wait to get the data and then use it, we can use await. Another concept in JavaScript is creating modules and closures, especially with ES6 Plus. A module is basically a file with its own scope. We can create a file, set it as a module, and this will not leak into global, and we can import that module, we can export that module as needed. A closure is a function where we can have a variable and from a surrounding scope itself, even after the scope has closed. For example, here we have a function called create counter and we have a variable. This method or a function actually returns another function which increments this variable. It accesses the outer variable. So when we call create counter method and set it to a const, it's basically this function that gets set here. And when you call that as counter, you can see that the outer variable actually gets updated. This is a classic example of a closure. As I mentioned before, we have imports and exports, especially in ES6. So we can export a const, we can export a default function. So this is called a named export and this is called a default export. Named export is when we want to share multiple things from a file, but a default export is the main tool or the fallback tool of the file. We can have only one default export per file, but we can have multiple named exports in a file. So for example, here we have a named export py and we have a default export function add. When we are importing it in a different file, we can have import statement, and we should also remember that named exports will go inside the curly braces, but default imports are always outside the curly braces in the import statement. And here you can see that both of them work fine. Another thing in ES6 modules is that when we import it in the HTML file, we have to put it in the script tag, and we should definitely set the type to module, and only then it will work. There are different ways of loading a script, the JavaScript file. One way is to write it directly as an inline script, and that's the script tag in the HTML file itself, or we can put it in a different file and add it to the script tag usually after the main content or the body of the page. And the final way is adding it as a module. And as I mentioned before, the DOM, which is the document object model, this is the browser's in-memory tree representation of the HTML page. So all the elements in the HTML will be treated as nodes and they will be stored as a live tree in the browser's memory. JavaScript can query and modify any of the HTML nodes to create any interactivity or data loading changes, etc. So to select the element, there are multiple ways. One common way is to set document.querySelector, and we can modify the content, we can modify the style, we can also add event listeners to it for like click, hover, etc. And then we can change the value as well. So most data loading changes and interactivity is usually defined in the DOM. So every block that we saw till now lives in the browser. It is all client side. So if we only need client side rendering, which is a static front end, where the browser requests static files like HTML, CSS, and JavaScript, we only need a HTTP server, no server side logic. But in most modern applications and websites, we will need a server, and that will point us to three-tier architecture. And for that, we can use Node.js. So Node.js application server will sit between the client and the database. So database will have some data, and the Node server will handle all the routing, the business logic, fetching the data, etc. Express.js is just a framework that sits on top of Node.js that makes the routing part easier. So in this example, you can see we can use the Express package, and for example, we have a URI like /API/users. It is very easy for us to point to the server and basically just handle the routing. Another important concept in the server-side rendering and generally for web applications is the HTTP protocol. There are some common methods in the HTTP protocol like get for reading, post for create, put and patch for update, and delete for remove. In a typical HTTP example, we will see the HTTP method, some headers, maybe an optional body, and the server always responds with the status code and headers and body. If 200 OK means all is good. And we saw this classic example at the start of the video. A URL is basically just an address at which we hit the server to locate a resource. It has different parts. It always starts with the protocol, which is generally HTTP or HTTPS, and we can have the user and password for authentication, but in most modern URLs we do not use it anymore. We can have the server, the port, the path, and we can also have optional params or query params and some client-side fragments as well. And finally, let's go to data. All the way at the bottom, we have data usually stored in databases. There are multiple types of databases and they store data differently. Some of them will store them as rows and columns like a table. Some of them can be as files. And in this course, we are mainly going with MongoDB, which stores data like JSON-like documents, and they are usually grouped in collections instead of rows and tables. We can use MQL, MongoDB query language, to handle the data like retrieval, update, etc. A typical JSON document would look like this with underscore ID, which is a unique identifier for the particular document, and key value pairs. There are multiple ways of running MongoDB. If it is just for local development, we can run it up with Docker, but if we want to use a managed cloud service for deployment purposes, we can use MongoDB Atlas. Other type, we have multiple MongoDB clients as well, where we can manually or visually see the data that we are dealing with. For interactive shell, for running the MQL commands, we can use MongoSH. If we want a GUI to browse the data, we can use MongoDB Compass. And if we want to connect to the Mongo database from our Node.js app, we can use the Node MongoDB driver. For handling the data for retrieval, update, and insertion purposes, basically for CRUD operations and other transformations on top of it as well, we have two options. The first is query operations. MQL queries are just plain JSON objects. For example, we are connecting to the database and we are tapping into a collection called users here in this example. A basic query we are just adding find and a JSON where we send a key value pair. We have multiple options like finding, skip, limit, project, sort, etc. We can also do regex match. When we move to aggregation pipeline, it is just a sequence of transformations that we can apply to a collection. For example, on this collection orders, we can aggregate, put a filter, we can group the data, we can join with the collections, we can sort the results. So we have multiple common stages that we can use to transform the output of each stage and feed it to the next. Alright, so we've mapped the whole stack here, every single layer and the important concepts in each layer. We started this video by looking at the network tab. We saw dozens of requests getting fired on a page load. So let us try creating that from scratch and watch it all happen. So before we start writing anything, there is one concept that we need to understand first. Async. JavaScript is actually single threaded. That means one thing at a time. So if we make a network request and just wait for it, the entire page will freeze. No clicks or animations, nothing, and the thread is just blocked. Async is the solution. Instead of waiting, JavaScript will say, go do that, and when you're done, call me back. The thread stays free to handle other things in the meantime. That's what async and await is about. Syntax that makes asynchronous code read like synchronous code without actually blocking anything. Under the hood, it's all just promises, and promise is just an object that represents a value that isn't available yet. It's either pending or resolved or rejected. And async and await is just a cleaner syntax on top of that. To start with the demo, we can just create a HTML page and a JavaScript page. Alright, so in the index.html, let us create a basic HTML structure. This is our demo site, and let us see how our live server is rendering it. And here we see hello. That's great. So let's open our web dev tools and go to our network tab. Now, for the purposes of the demo, let's use a public API so that we don't need any setup. So I'm going to use JSON placeholder website API. So here we have some examples for like if we run this code in any console or form from any site, we should be able to get this response. So we can use this. Let's go to a demo site and let us try running this in our console. We can see the promise was pending and it took some time and we got the response. In the network tab, we can see that there was one call. We have a header. It was a get call. And we have the response preview as well. So fetch. This is the HTTP request. It returns a promise. Await pauses this function until the promise resolves, but it doesn't block the thread. Then response to JSON will pass the body. That's also async because it's reading a stream. So we have to await that too. So let us change the syntax a little bit so that it is similar to the async await syntax that we saw earlier. Let us start an async function, get to-dos, open the function, const response. We need to fetch the data. This is the endpoint we are going to use. then we need to get the data from the response. So wait, we have the response here, and it gets the JSON from it, and we can log it by logging the data. That's it. Great. Now let's see if it is saved correctly in the console. Great, we have our async function here. Now let's call this function. The same thing, you can see a promise is pending, and it took some time, and we got the response. Alright, so now we saw how async and await works, and we saw it in the console, which is great for debugging purposes. But now let's put it in the JavaScript file so that we can see how it works along with the HTML file. So in our HTML file, let's replace the index.html with an unordered list, and we can actually give it an ID that is easier. We can point it, so it is to do list. Great. The content is going to be empty because JavaScript is going to fill it for us. Let's go to app.js. Oh, and for that we need to link the app.js here. So we have script tag, and we can divide src, which is app.js. Let's see if it is linked properly. It is linked properly. Now we can go ahead and add our get to-dos list function here. So let's create an async function. The name is going to be get to-dos. We don't need any params here. First, let us fetch from the endpoint, and we have our endpoint over here. Now for the fetch, we need to add an await, and we need to put it in a variable, so or a constant. Let's put it in const response equal to await fetch. Now once we have this response, let us get the data from it, which is const data, and we can get it from response.json. Now we need to use a query selector from the DOM and get the list HTML element. So let's get const list equal to document dot query selector, and we used an ID, so it is hash if it is to-do list. Let's confirm it. Yes, to-do list. Now once you have this, now we have the HTML element. For each data item in the response, we will need to add a list item to the HTML list tag. So let's do data dot for each. For each element would be a to-do, and here const, we are going to create the element first, so it's li list item. So we have a document create element. We are going to create an li element. Now we are going to set the li element text content with the to-do. Let's see what the data is. We have the title. Let's set it with the title. then we need to set this li item to the list. So let's append child here, append child, and that's it. Now let's call this method, because otherwise there will be no data here. Once you call this method, also let's add a console statement so that we know it is getting called. Okay, and that's it. Here you can see that in the console we can see the console log statement, and you can see the HTML list element getting populated with several list items from the endpoint. Let's go to the index.html, and here you can see that it is a successful call, get call, and we can see the response preview, which is empty because when the HTML page loads there is no data. But then app.js also gets loaded and this method would get called, and that would cause a network call. And here you can see the network call has been made and that data got updated here, and that's it. So now we can see this query selector finds the UL element in the DOM tree, and it updates the text content. That is it. So we have a data from the server rendered onto the DOM, and it is completely driven by JavaScript. Alright, but there is one more thing we need to consider. What happens if the fetch call fails? Maybe due to bad network issues or server down issues, or even if it's the wrong URL, the function will just silently break, and in production cases that's completely unacceptable. So we need to add error handling to this code. Let us first put the whole thing in a try catch block. So with a try catch we can handle any exception that might arise. So let's catch the error that comes up, and we can log the error. So console.error, and here we can just say failed to load tools. Great. Now let's log the error as well. Now we also need to say, or for the response, what if the response is not 200 okay? So for that case, we need to manually throw the error, because if it is something other than 200 okay, which is like 404 or 500, we need to throw manually, because the fetch itself does not throw on bad status codes. Only on network failures it will show up in the catch block. So for other status code issues we need to throw it manually. So let us get the response. If it is not response.okay, let's just throw the error manually. Let's just say http error with status, and it is response, or I think status is okay. So then after this, as usual, we get the data, we get the list, and with the data we update the DOM. This should work. And that's it, that's the full loop. We opened this video watching requests fired in the network tab without knowing what was behind them. But now we've built one ourselves, just 14 lines of JavaScript. It gives us a HTTP request, a promise resolving, and the data hitting the DOM. Every row in the network tab is just this: someone's fetch call, browser resource request, an API response. It is just HTTP all the way down. The only piece we didn't build live is the other end, the server side, the express route which receives the request, and the MongoDB query which is running behind it, and the JSON coming back. But now we know exactly what's waiting there. So that's the whole stack. Thank you so much for watching.